So the type of join we use will help us determine whether a row gets returned in our join table or not. So the inner join, which we just created by running this block of code, works by looking for matches in both tables. And the inner join process says return all columns from both tables, but only return those rows where there's a match in both tables in the columns we're joining on. In this case, County Phipps or Byer County and Byer State. So the way this is often represented as a Venn diagram is, Table A and Table B contain some overlapping information that we're joining on, and only return those records where there's a match. That's why the inside of this this little wedge here is pink. Because if there's not a match, then the row would fall inside of this white area, and it would be excluded. So again, I'm going to pull up the table here. So here's our County Pills population table. Let's just take Autauga, Alabama. So there was an entry for Autauga, Alabama in our Pills table. You can see right there. There was an entry for it in our population table. You can see it right here. Because these three columns in population match what we had in Pills, that's why Autauga, Alabama made the cut. That's why this row made it into our joined table, which we see here, where we have the value for Autauga and the average Pills per year and the population. So again, what I want us to look at here is the number of rows, and we can start to get a sense of how the inner join is working behind the scenes. So the population table has 3,143 rows. That is, our population data contains information on 3,143 counties, if we consider that each row is supposed to be a county. Our Pills table has 3,130 rows or counties, so maybe we don't have information on certain counties. And the joined one has 3,036 rows, which is fewer than either of these. And again, the reason for this is that indeed there are some counties in our population table that do not exist in our Pills table. And this is pretty common, by the way, when you're working with joins, to have different numbers of records in different tables. Because in the real world, when we're putting together data sets, it's not always nice and neat. I want to give you an example of this. So our Pills table, which I'm going to pull up here, I'm going to throw on filters, and I'm going to type in PR, which stands for Puerto Rico. So what we can see here is there's a number of counties in our original Pills table for counties in Puerto Rico. Okay, so PR is in the Pills table. But when we go look at the population table, and I put on the filter again and type PR, you notice our population table doesn't have any counties on Puerto Rico. So with the inner join process, when we do this match, these counties in Puerto Rico are looking for a corresponding match in the county population table. There isn't one. And because there isn't one, that table is that record is not joined in our final join table. It works the other way too. So, for example, in our population population table, we have some information for Bristol Bay, Alaska. So we have a record of the population. It's a very small county in Alaska, Bristol Bay. When we go to look at our pills table, I'll type in Alaska. I'll type in Bristol. We don't see Bristol here. There was no information reported about opioid shipments to Bristol. Maybe there were none. Maybe it wasn't in the data. So again, Bristol exists in our population. It doesn't exist in our pills. And so when the join was doing this work, because it didn't find a match in both tables, it left it out. So in this way, we end up with a smaller number of records in our join table by doing this inner join process than we would have than existed in either of the other tables. So again, inner join, looking for matches. And if it finds a match, it's going to return that record. But if it doesn't find a match, it won't return it. Okay, move on to the next one.